Hi everyone, and welcome. In this problem, we have a semicircle with center O and diameter AB. Segment AC lies along the extension of the diameter, and segment CD is tangent to the semicircle at point D. We know that CD has a length of square root of 3, and AC has a length of 1. Our goal is to find the area of the shaded region. This is an interesting one. Before we start solving it, I want you to pause the video and try to solve it yourself. If you find the answer, let me know in the comments below. Now, let's solve it together. First, let's connect the center of the semicircle to the point of tangency D. We know that a radius is always perpendicular to the tangent at the point of contact, so we have a right angle here. Also, this segment is a radius of the semicircle, so let's call its length r. Now we have a right triangle. Using the Pythagorean theorem, we know that the square of the hypotenuse equals the sum of the squares of the other two sides. So we can write the equation as r plus 1 all squared equals r squared plus the square of root 3. And we know that when we expand a squared expression, we get a squared plus b squared plus 2ab. So let's expand our equation. After simplifying, the r squared terms cancel out from both sides. Now, subtract 1 from both sides. This gives us 2r equals 2. And finally, divide both sides by 2. So, r equals 1. Now we know that the three sides of our right triangle are 1, 2, and square root of 3. Here's an important observation. In a 30, 60, 90 right triangle, the side lengths are in the ratio n, 2n, and n times the square root of 3. And if you look carefully, our triangle has exactly this ratio. So its angles must be 30, 60, and 90 degrees. How interesting! Now, let's look at the shaded region. We can see that its area is equal to the area of the right triangle minus the area of this 60-degree sector of the circle. Let's start with the area of the right triangle. The area of a right triangle is 1/2 times the base times the height. The base is 1 and the height is square root of 3. So, the area of the triangle is square root of 3 over 2. Now, let's find the area of the 60-degree sector. A full circle has 360 degrees, and its area is pi times r squared. A 60-degree sector is 1/6 of a full circle. So, its area is 1/6 of the area of the circle. That gives us pi times r squared over 6. Since the radius is 1, the area of the sector is simply pi over 6. Therefore, the area of the shaded region is square root of 3 over 2 minus pi over 6. And that's our answer. Pretty neat, right? I hope you enjoyed this geometry challenge. If you found another way to solve it, let me know in the comments. And if you enjoy geometry challenges like this, don't forget to subscribe to Sweet Math. Thanks for solving it with me, and I'll see you in the next challenge.